Well, good afternoon, folks. Welcome to this University of Southern California Institute for Addiction Science research seminar. We're really pleased to have Dr. Justin Strickland. Before I get started, I just want to give a little background about our institute. So as Institute of Addiction Science here at USC, our goal is to integrate and promote collaboration across various schools at USC to support transdisciplinary research, education programs, and community engagement. And so as part of our mission, we like to educate folks on the latest happenings in addiction science. And we're really fortunate to have Dr. Strickland here, who has a wealth of information on various aspects of the addiction science arena. So a little bit of background about Dr. Strickland. So Justin has a bachelor's in psychology and biology from Davidson College in North Carolina, where Steph Curry went. But they also have great research there. And so, there he focused on preclinical addiction research methods. And then he then moved to University of Kentucky, where he got his master's and his doctorate in experimental psychology. And there he transitioned to human research, really developed a really interesting research program focusing on cocaine and other types of drugs. And he's been at Hopkins since, I think, about 2019, first as a fellowship and then also more recently as a faculty member. And so Dr. Strickland works in a lot of different areas of addiction science. He's probably most known for his research on behavioral economics and some of the theoretical frameworks he's used in that area to address addiction and also sexual health. A very translational research program that he oversees, focusing now on a number of different addictive drugs, from nicotine to opioids, and I already mentioned stimulants. And he's also interested in the behavioral mechanisms that underlie psychedelic drug effects. So he's gotten a lot of different grants from the NIH and published over 100 papers. So it should be really interesting to hear Dr. Strickland speak. So let's give him a warm welcome.
Thanks, Dr. Leventhal. Thank you all for being here, both virtually and in person. So today I'm going to be talking about, I gave a title a while ago and I left it very specifically vague so I could kind of talk about whatever I would want. So I'm going to talk about behavioral economics for translational substance use research and kind of operationally define that at the start. Let's see. There we go. Just briefly my disclosures, but nothing relevant to the talk today. And so, as I said, a very kind of vague and general title, so I had a lot of flexibility to talk about what I wanted to. But what I like to do kind of from the start is operationally define what I mean about behavioral economics and what I mean about translational research, and for reasons I'll discuss in a moment. And so behavioral economics, what does that mean? At sort of a broad level, many of you probably know about behavioral economics for what I like to think of as behavior of economics. So this is the use by economists and other folks that work in economics, primarily microeconomics, of psychological principles to understand economic decision-making. And so this often manifests in things like choice architecture and nudge interventions, popularized by folks like Richard Thaler and Daniel Kahneman, and thinking about how these subtle manipulations in the environment can influence choice and decision-making, and bringing in things from psychology like heuristics and other choice biases that might inform those things. And while this is absolutely a really cool area of research and a very important thing, I'm going to speak mostly nothing about it today. Because what I do is more within this realm of the economics of behavior, and a lot of the work that I do is within this space. So this is thinking about how can we bring microeconomic principles and ideas that have been developed in economic decision-making into what we do as behavioral scientists, psychologists, and folks working within decision-making science. So this is things like how the impact of cost alters decision-making, or decision-making as an altered cost sensitivity, the impact of delay or the devaluation of future consequences on decision-making, and decision-making as restricted alternatives, or the impact of alternatives in the environment. And so how these various features of decision-making may impact health and decision-making, specifically what I'll talk about today, substance use and substance use disorder. And so the other half of this is translational. So this is sort of the go-to slide of talking about translational research, the sort of systematic pipeline within a medication or behavioral science, a behavioral intervention development pipeline going from preclinical research through phase trials up to the population level or community level. And this can involve a whole bunch of models and model organisms, so things like preclinical research with rodents and non-human primates, looking at drug self-administration and drug reinforcement. We can talk about human laboratory work, where we use very precise control over laboratory conditions to understand and translate these preclinical findings to a human laboratory setting. The clinical space, where we start to work in the real world and think about the clinical intervention and the application of that clinical intervention. And then finally, although maybe not discussed quite as much, how that impacts at the epidemiological level. So seeing how interventions impact trends in substance use and the ways that people are using drugs and being treated for substance use at that broader level. So I've presented this as this kind of very nice logical stepstone, but really it looks something like this, where we take laboratory work and we go back, translate to the preclinical level. We think about what's happening in the clinic, and that helps us do what we do in the preclinical world or in the clinical human laboratory world. And it's all sort of this mismatch. And my title is a little bit of a misnomer. That's about as translational as I'm going to get, maybe, and I'm really going to focus on this human laboratory piece today, although bring in some of the flavors of these other spaces and how they've informed what we do, as well as how we're informing what's being done in these different clinical venues. And so I was thinking about what I was going to talk about today, and I kind of wrestled with a few ideas. And so I decided on was to kind of do a tasting menu of sorts of the various areas that I work in across this behavioral economic sphere, and thinking about the ways that we measure these various decision-making biases or decision-making features. Talk a little bit about measurement and how we conduct these studies, and then give some practical examples of how they apply in a preventative realm, in a treatment realm, and a clinical realm. And so first, talk a little bit about decision-making. It's this devaluation of future consequence. And so very simply, what I mean here, for those of you familiar with this realm of research, is the notion of delayed discounting, or the systematic decrease that we see in the value of a commodity as a function of its delay to its receipt. And so sort of the simplest example of this is the devaluation of money that we see as a function of delay to getting it. So the value of $10 given now versus, or the value of some money given now versus the larger magnitude given in the future. And what we get from looking at these discounting functions or thinking about discounting is this systematic decrease, where we see this devaluation or this decrease in the value of money as its extended time scope, or the further it goes out. And we can see variations in this amount of discounting. Some people tend to be steeper discounters, so that in the circle, open circle here, where that money is devalued very steeply and very quickly, versus someone who's rather shallower in discounting, who sees less of a steep decrease. Now, conceptually, we like this, or we think about this a lot within substance use and other health behavior, because there's a lot of conceptual links to when we think about decisions that are made within a clinical setting. So sort of the prototypic example of this is the choice to smoke a cigarette, which is a very potent immediate reinforcer, over the more long-term life goals that we might have of health, behavior, or healthy life, the lack of lung cancer, the ability to do things long-term that you may not if you continue to smoke. And conceptually here, there's this devaluation of that future benefit in terms of the healthy lifestyle goal over the shorter immediate benefit of cigarette smoking. We can measure this a whole host of ways in the lab. Just one simple example here, and sort of the conceptually simplest, is we can do very simple questionnaires asking folks the value of some smaller reward today or a larger reward at some future state. So this is just a sample item from the monetary choice questionnaire in CQ 27. So would you rather $54 today or $55 in 117 days? And what's nice is we see, when we look at discounting rates or this devaluation, we see very stable rates over time. So if you reassess these measures, you see stability over time. Here we just see it at the aggregate level in terms of the distribution. where in just this example, from May 2020 up to April 2022, very stable rates at the group level, and of course, reliability at the individual level. Just kind of hamper that home. So this is some data that Brett Galino, a postdoc working with us, has worked on. So this is a meta-analysis of all the discounting studies out there that looked at that reliability coefficient here on the y-axis. And what you see is, of course, there's variability in the reliability of these measures over time, but they tend to show pretty good reliability up in the 0.7, 0.8-ish range on average, which for a behavioral measure or a sort of behavioral-like measure is a pretty good reliability for test-retest. I'm not going to talk much about probability discounting today, but you actually see better for delay than probability, which is conceptually interesting. You also see better stability for money versus other goods, which conceptually makes sense in the context that money is a very stable commodity versus things like the value of drug or the value of food or the value of some other commodity likely more fluctuates over time in the environment. And sort of notably too, when you look at the reassessment time of these various studies, you see, of course, this bunching around 1 week, 30 days, 90 days, that's what that represents. But even when you go out to these years out, you still see good reliability of these metrics up in that 0.7, 0.8 range. And so that brings up sort of conceptually an interesting question about discounting and how we think about discounting. So in one way, we often think about it as this trait-like measures, this stable feature that we expect to remain the same over time, that people are either high discounters or low discounters, and that's this just core feature, personality-like function. But on the other hand, we know that these sort of response profiles are also a function of the environment that one is in. Sort of the prototypic examples are in environments that show acute environmental distress or individuals that show acute income shocks or immediate decrease in income. We see a shift in discounting where folks will adopt more of a smaller, sooner response pattern, which is frankly adaptive. We would expect people in an uncertain environment to favor immediate consequence. And so we can think about this sort of kind of stable trait level that we're often capturing in the questionnaires that we use and the things that we measure. We'll recognize that there is that fluctuation that is highly dependent on the context and the person in contact. So in a scarcity context, we would expect an increase in discounting where people become more reliant upon that immediate choice strategy. And in a satiety context or one where there's favoring of a longer consequence, shift downwards or less discounting. And of course, that brings up the question of what does that trait come from? It likely comes from things like genetic predisposition, but also the behavioral history that one has. So this accumulation over time of exposures to the environment or interactions with the environment that favor one strategy or the other and would shift someone towards that sort of pattern. So I say all that because today I'm going to be talking about sort of the pragmatic example I give of this sort of more trait-like understanding and thinking about discounting as this more risk factor than a malleable factor, but recognizing that there is that malleability. And so the study I'm going to talk about is a recently completed human laboratory study led by a colleague at Hopkins, Dr. Kelly Dunn. Dr. Dunn does a lot of work in opioid use disorder and opioid use risk. And so she led up a study that was a huge undertaking. So a human laboratory study of hydromorphone, which is a mu-opioid agonist, so like oxycodone or other opioid agonists, and looking at 100 folks that were largely opioid naive, and even amongst the non-naive, it was all like prescription. So you got opioid when you had your wisdom tooth taken out. So nothing that was a non-medical use profile. And looked at the response to oxycodone across this full dose response range from 0 to 8 milligrams within a residential clinical environment to see what predicted the response to the opioid and the abuse liability of opioids. Because when we think about the clinical setting, the goal is hydromorphone and other opioids are clinical tools, but we want to know who is higher or lower at risk in terms of developing that trajectory of opioid misuse and opioid use disorder. So one of the things that we've done with these data is think about, at a sort of simplistic level, the sensitivity to opioid agonists and to opioid response. And so one way to think about this is sort of in FDA parlance, drug effects or subjective effects in response to a drug. When we talk about human abuse potential studies or abuse liability studies, this is a key metric that's used by the FDA to differentiate a drug that may or may not have abuse potential. And so what we've done is we've looked at, across these doses, individuals who showed low dose sensitivity, meaning they first detected a drug effect at that 2 milligram dose, medium, so 4, high, 8, or someone who showed no sensitivity. So this is an interesting group where even at that 8 milligram dose, which is a pretty hefty dose of hydromorphone, they still failed to report any drug effect or any experience of a drug effect, which can't be attributable to something like tolerance, because this isn't a group that has previous opioid exposure or opioid sensitivity. And you can see actually a large group of people, about 31%, show that. Two groups I won't talk about today are folks that respond to placebo. So these are people that just feel drug effects all the time. Anyone who's done a human lab study, this 1 in 10 makes a lot of sense. You get that 1 in 10 person who comes in and they're like, man, this placebo is making me feel good right now. Or the extreme sensitivity. So this is someone who probably has a genetic polymorphism or another reason, metabolic reason, why they're sensitive to opioids. So extreme sensitivity, this referred to stuff like vomiting or other sort of extreme sensitivities that resulted in discharge from the study. And so just show that visually, you can see here low sensitivity group, medium sensitivity, high sensitivity, no sensitivity. This is like I'm showing a median split and showing the results lining up like they are. This is just sort of the definitional differentiation of these groups. One thing to notice though is that if we look at the actual kind of peak values, they align more or less in terms of the effects of the drugs across these sensitivity groups. It's just simply at what dose that sort of kicked on. And so what I want to talk about today is one of the risk factors that we've looked at, which is discounting, the extent to which that maps onto these various response profiles. And so on the x-axis here, we're going to look at those 4 groups: no sensitivity, low dose, medium dose, and high dose. And I was going to say, for those of you who are colorblind, I apologize because I used color, but it appears that the color has disappeared. So lucky you, you'll be all good. And that's why you label your axes as well. On the y-axis, we have the proportion of larger later choice. So higher here is lower discounting. So less impulsive or less choice for the smaller sooner reward. And so we look at the no sensitivity group, and both at the individual subject level as well as at the mean level, we see this fairly low discounting, so more choice for the smaller sooner reward, which we can contrast with these other groups where we see both at a distributional level as well as at the aggregate level, this higher choice for the larger later reward, which would be less discounting. And just show that a little bit more simply, when we collapse those any sensitivities versus no sensitivities, fairly decent effect size, so about 0.6 differentiation between these groups. Where the group with any sensitivity to opioid agonists showed more choice for the larger later outcome. Now, what interesting feature of the study is we also had the benefit of being able to look at folks pre and post drug administration. So that was baseline. But what about the response to the drugs? So sort of an environmental permutation of discounting, as well as for the pre-dosing, a sort of replication of this response profile or differentiation response profile. And so, again, apologize for the lack of color, but sort of dose-wise, no sensitivity, low dose, medium dose, or high dose. We see the similar sort of rank differentiation, which is remarkably consistent across the sessions. And so very similar, if not identical, pattern of effect. So giving some certainty to this differentiation, which again, we can kind of see at the individual level where imagine this bar is white and this bar is black, no sensitivity and any sensitivity, where we see this greater discounting in that no sensitivity group. And so the no sensitivity group is a bit interesting because you have this sort of twofold thought of, well, shouldn't people that don't respond to opioids be at less risk? Lower sensitivity suggests that they're not going to experience the euphoric or high related effects of an opioid, which is possible to some degree. But when you look at other literature, there's a decent amount of literature, at least an interesting literature in the alcohol world, showing sort of a similar pattern where you have a group that has a lower sensitivity early in life to alcohol use, and that group has later in life a lower or a higher propensity to develop a 4 times higher likelihood of developing alcohol use disorder. And some of the rationale here is that the groups that show lower sensitivity to a drug early in their experience are less likely to come in contact with those negative contingencies that come with drug use. In the case of alcohol, hangovers or other negative consequences, sedation that you might feel on acute use. And then in the case of opioids, the negative feelings, the nausea, the bad effects that come with opioid exposure. And so while you may not feel necessarily that high, you're also not going to feel that negative consequence that deters a lot of folks from that initiation of use. And so what's interesting here is we're also seeing this borne out in terms of one of the risk factors that we have in terms of predicting later substance use, and that we've kind of posited as a field to be predictive of negative consequences of substance use, this discounting profile. And so just to kind of tie out what talking about discounting a bit, I'm doing some work with Julia Felton, Brian Mayer, and Jill Rabinowitz at, despite the background, not Michigan State, Henry Ford Health, Johns Hopkins, and Rutgers. So we're working with ABCD, the large national cohort data set, tracking children over a 10-year span, and looking at this sort of combination of that state and trait-like features that are predicting long-term risk with discounting as well as substance use. And so a lot of the folks here are geneticists, and so we're thinking a lot about that predisposition, that genetic risk. And so just as a snapshot of that, what we find is that looking at all these polygenic risk scores, so these are sort of an aggregate way of thinking about genetic risk at various single nucleotide polymorphisms aggregated over the whole. We find that the polygenic risk for delayed discounting well predicts in early life the phenotypic expression of discounting, so the sort of genetic to phenotypic expression connection. I should note that that polygenic risk score is for adults, so this sort of it appears to be even early in life that's expressed. But one thing to emphasize, and this is sort of important to think about in any of the genetic work we do, a lot of that research and the development of these polygenic risk scores are on primarily European American ancestry samples. And so when you look at the prediction in children that are identified as African American, within the ABCD data set, you don't see that prediction. So kind of speaking to the work we need to do within genetics and thinking about diversity within our discovery samples. And then just to kind of emphasize the sort of broader importance of thinking about some of these features and measuring them within clinical contexts. So this was some work I did while I was back in Kentucky with folks out there, Brady Reynolds, who's the PI on this project, looking at a contingency management program for adolescent smoking. And so CM, or contingency management, for those of you unaware, is the incentivization of some target behavior such as smoking abstinence with the provision of some reward, either money, gift cards, something like that. And so what was found in sort of the parent study, which is no surprise, is that active treatment, so the provision of those incentives, decreases smoking in adolescents, like it does in nearly every other CM study, relative to a control. But what was particularly interesting is that this was more or less isolated to the children who showed that lower discounting or less discounting profile. So the higher discounting children, the children that showed that more immediate or devaluation of the future consequence, showed less of a clinical impact, which is actually somewhat troubling. We were just talking with some folks earlier about CM and how it really leverages the fact that you need to bring the treatment closer in proximity to the individual. And in this case, even bringing that a little bit closer, so making that tangible effect more readily there, the tangible health benefit of quitting smoking still didn't necessarily do it here. And so kind of emphasizing the importance of some of these baseline characteristics in terms of predicting treatment response. And so my little first appetizer, the tasting menu or whatever you want to call it. So delay discounting reflects the systematic decrease in value by delay. It's conceptually related to substance-related decisions. We discussed a little bit this sort of difference between trait-like and state-like features. We do know that trait-like features, or at least that aspect of it, when pulled out, shows good reliability and stability over time. And that some of these features may predict risk prodromal to the development of a substance use disorder. So sort of the age-old, is it a cause or consequence? There at least to be an association between discounting and the future risk or the potential risk of substance misuse, and thus a preventive target-worthy investigation. So it was a little bit about discounting. Now the sort of other kind of flavor of behavioral economics that we think about a lot, this notion of demand or decision-making as an altered cost sensitivity. And I'll frame this a lot within medications development, which I've spoken to some of you is a lot of the work that I do. So at the simplest level, demand is sort of this weird version of what we do in the behavioral science literature of what economists do, and thinking about this relationship between the cost of a good and its consumption. And so the axes here and the plot will look very weird to anyone who does microeconomic work. But what we're talking about here on the x-axis is the price of a good, on the y it's consumption. When we plot these in our worlds, we get these very, well, this is just the lines connected, but we'll get these very systematic demand curves where it's this negatively decelerating function, where we can talk about relatively inelastic parts of a demand curve, where there's less sensitivity of change in consumption to change in cost. So consumption will stay the same despite changes in cost. Relatively elastic parts of the demand curve, where we see this very rapid change in consumption as a function of cost. And what we'll often do thinking about these within a addiction science world is separate these two key features of reinforcement or reward. Q naught, so demand intensity, which very simply represents consumption at unconstrained costs. So the open bar, the buffet meal, how much are you consuming when there's no, at least cost as described. And then elasticity, which is a metric that we can derive that is at a kind of broad level, the sensitivity of changes in price, or changes in consumption to change in price, so price sensitivity. At a very sort of mathy level is this scaling parameter representing the individual point slip changes in elasticity, which are the tangent lines on the curve all the way across of it. So it's sort of a parsimonious way of describing the curvature of this function. And so we can think about goods that are relatively inelastic. Gas is a good example. Gas can get really expensive and we'll still buy about the same amount. I was running around earlier. Gas is really expensive here. Yeah, it's very expensive. It was like, I don't think I'd have a car, but you know what? I'd probably still have a car. And I would probably buy the same amount of gas or near the same amount. Candy, on the other hand, is really inelastic. I don't buy that much candy, but when I do, I don't spend that much money on it. But something really important I like to emphasize here that I don't think is emphasized enough when we talk about these things within substance use and also just broadly speaking, is that these aren't intrinsic properties of the goods themselves. Gas isn't intrinsically inelastic. Candy isn't intrinsically elastic. They're this dynamic interaction of the person, the environment, and the context that they're in. So Halloween was just a couple of weeks ago. Candy was a pretty inelastic good for a lot of us. Candy gets marked up. We have the need, this functional need to buy candy that we'll give out to children. And so we'll still show a pretty inelastic pattern of consumption for candy, something that normally under a typical context would be pretty inelastic or pretty elastic. And so it can both change across time and space, across people. Traditionally, we've measured this in the lab using sort of orthogonal procedures or parallel procedures of how we measure them preclinically. So we can have these response operandums. So this is just looking at our smoking lab where we do puff topography and drug reinforcement sessions. And we get these Lindsley plungers that people can pull on. And we can vary the fixed ratio cost of receiving smoking bouts and measure a demand curve across a range of prices and for a range of commodities. Here, just an example of full and reduced nicotine cigarettes. Now, this is great, and it's a way to tie this directly to behavior and observable behavior that requires some effort, and we can manipulate and observe and all that great stuff. But it's very time and labor intensive, so it requires this very complex equipment, or at least not cheap equipment that requires maintenance. And it also requires, just here as an example, a participant to come in 1, 2, 3, 4, 16 times if you look at every data point here, because each of these is an individual session. Anyone that does human participant research, participant coming in 16 times is not fun. And you're likely to have attrition and weird selection bias and who has the time to come in 16 times into the lab to do something. And so one of the ways we've sort of started to think about working around that is using the purchase task procedure, which is a procedure in which participants are presented with a vignette that relies upon verbal behavior manipulations to present a context that someone has experienced or has experience being in to evaluate demand in that way. So here, just an example of the alcohol purchase task. Think about a typical day once you drink. You have no access to other alcohol products, so presenting a closed economy, there's no access to other alcohol outside of this. You can't stockpile or sell it. And then we can go through a range of prices, asking how many drinks would you purchase, assuming that they were that price, and generate these same sort of demand curves as we would using those operant procedures or those effortful procedures. And so here, just an example of an alcohol demand curve, here, cannabis demand curve for hits of cannabis, which just operationalizes 0.09 grams. So it could be very, very tiny bit. And what we see is that we can generate those same Q0 and elasticity values and relate them back to measures of frequency of use or severity of use, and they show good convergent validity in the same way that those measures we generate in the lab and generate through those much more intensive and long-term procedures do. And just to drive home a few kind of things that come up when we talk about the purchase task procedure. So we also know that when we look at folks with and without extensive experience, so we have the opportunity of looking at sort of a large cohort of people that either had been exposed to this task before or not. So is there an experience-dependent effect? We see very little difference. So this is between subjects, so it's not a stability necessarily, but distributionally, they look nearly identical. So the same population of people just based on that exposure. So both in terms of intensity value as well as the elasticity value. And the eyeball test tells you they look the same, but also the math test does as well. Another thing that comes up all the time is this sort of the hypothetical nature of purchase tasks. I'm not going to dwell too much on that, but I'll show a little bit of data and we can talk about Q&A if of interest, because I think it's something that interesting to think about. But when we look at the relation between these hypothetical procedures, which have the benefit of flexibility and disseminability, and the relationship with a task that's incentivized, so you're actually carrying out the money exchange and the drug exchange and the use of it. Here's just an example from a study we recently completed with cigarettes. So looking at cigarette purchase task and actually buying cigarettes. You're pulling out poker chips for and doing an exchange of money. We see certainly not the same, maybe, there it is. Oh no, too far. Certainly not the same exact values. So here, this is data from about 80 individual sessions, no, 100 individual sessions. The darker are when they're just the same value on top of each other. Certainly not the one-to-one correspondence for the same exact thing, but correlations that are about in the range of 0.6 to 0.65, depending on the metric we're deriving out of them. You get a little bit of the funkiness where you get some task-dependent values that they can only max out at a certain value, which is this guy right here. But by and large, a good correspondence between the two. Now, one of the ways that we've thought about incrementing the validity and the kind of veracity of these measures within the human laboratory environment and sort of marrying the benefit of this rapid data collection with the rigor and scientific control that we have in laboratory studies is by tying the consumption not to some hypothetical good, so a drink or a cigarette, but when we start talking about illicit drugs in particular, a quantifiable and experienced commodity. And so maybe Matt and Adam are kind of shaking their head like, yeah, we came up with that idea. So the idea here is that in a human laboratory study, we're doing some double-blind administration of a drug and actually tying the consumption of that to this hypothetical purchase task procedure to balance the blinded experience of a drug with the richness of the information that we get from those demand curves. And here's just an example of with D-amphetamine looking at differences as a function of placebo versus amphetamine, and some really interesting results here in terms of the prediction of risk. This was another really probably Herculean task study of looking at folks in prospective risk. And so the example I'm going to talk about today is how we've incorporated that within the medications development pipeline. And so the sort of bread and butter of a lot of studies we do are these phase 2A type studies, where we're looking at some novel medication that's FDA approved, and we're looking at its repurposing for the treatment of substance use disorder. Unfortunately, when we talk about medications for substance use disorder, there's no real interest at a pharmaceutical level for the development of a new medication. So what we get stuck with is co-opting existing medications and the mechanisms of action they have for this novel indication. And so here's just an example of sort of what those studies look like. Folks are maintained on a residential unit for some period of time. This was a long study, so it was a month long. It can be anywhere from a week to a month. And we're looking at the maintenance on that medication and the effects of the drug of interest, whether that be cocaine or methamphetamine or opioids, in terms of drug self-administration, safety, and physiological effects. And so the example I'm going to talk about today was a study I worked on while I was out in Kentucky with Bill Stoops and colleagues out there, looking at the medication suvorexant, which is dual orexin receptor antagonist for cocaine use. So a little bit about orexin. Promise you guys we hop around all around the translational sphere. Suvorexant functions as a dual orexin receptor antagonist, or DORA. And orexin is an interesting system in that it was only discovered, of course it always existed, but it was only really described in the scientific literature about 20 to 25 years ago, so right around the turn of the century, which is relatively new when we talk about neurotransmitter systems and receptor systems. In this sort of rodent brain, you can see, or not see, because it just is kind of a bunch of little tiny dots. A lot of the innervation of the orexin system is around the hypothalamus. And because of that orexin system modulation, orexin system signaling seems to have a lot of effects on various homeostatic states and survival behaviors and regulated behaviors. And so things like eating, things like sleeping, other motivated behaviors. We currently have 3 FDA-approved orexin drugs, and all 3 help in the treatment of insomnia. So this regulation of sleep state. And I should note, for those of you who are in the neuroscience world, orexin and hypocretin are the same thing. So hypocretin was discovered at the same time as orexin, and it's the same system, and 2 groups named it 2 different things. And there was this interesting marriage for a long time of, like, we called the genes hypocretin, but the drugs orexin and all this stuff. And then there's this messy divorce, and it seems like we've just all decided that we're going to call it orexin. And so hypocretin and orexin, same thing, more or less. Preclinically, there's a really interesting literature that goes back over a decade now, looking at orexin system modulation of drug reward. And so here, in sort of the spirit of translational research, some research from Morgan James and Gary Aston Jones up at Rutgers, looking at demand curves for cocaine as a function of orexin modulation. So this SB compound, which is an orexin 1 antagonist, decreasing cocaine demand, making it more price sensitive. So this curve flipping over earlier. So our hope is it does the same thing in humans. So on the x-axis here, we have price per hit. On the y-axis, we have consumption. So folks did 3 experimental sessions in this study involving 0, 10, and 30 milligrams per 70 kilograms intravenous cocaine. So those of you who don't have your little pocket calculator of intravenous cocaine dosing, 10 milligrams is like a good dose, produces reinforcing effects, but is certainly on the lower ends of that. And then 30 milligrams is a pretty hefty dose that certainly produces reinforcing effects. So nice dose response function there. So what we did in the session was, at the end of the session, after folks had experienced the full drug effect, asked, well, let's imagine that you got what you got blinded today and you were able to use it in the real world. How much of it would you be purchasing across these various prices? So that marriage of the purchase task and experimental procedures. Fortunately, we're under placebo. No one is taking much of anything, which is good. No placebo response. As well as, maybe importantly, suvorexant isn't altering the placebo response. There's no kind of suvorexant undertone that's creating a weird drug effect. And then with 10 milligrams of cocaine, we get this glorious, beautiful, different dose effect for 10 milligrams of cocaine. The unfortunate part is it's in the complete opposite direction as what you would want from a pharmacotherapy. So we have placebo down here at the bottom. We have 5 milligrams of superextant, 10 milligrams of superextant, and 20 milligrams of superextant. So that's the maintenance med and cocaine demand. So this very dose-related, it's clearly dose-related, increase in both demand intensity as well as a little bit harder to see, but I'll show it in a second, but decrease in elasticity. We see a similar profile for 30 milligrams, although a little bit of a ceiling effect kicking in likely because it's a higher dose that's a little bit harder to move, where the superextant dosing is increasing drug reward as well. And so we can see that in these kind of flavors, breakpoint, Omax, Pmax, and intensity, which are these metrics from the demand curve, where we see relative to placebo, this increase at that 10 milligram dose in particular. So a natural question is this just a bad measure? Like, are we doing something here that's mucking up what we would normally do in the human lab? Fortunately, in the study, we also had, because it was the main kind of measure of the study, a drug versus money choice procedure. So conceptually similar, although just looking at one monetary price, where folks were choosing between receiving an intravenous infusion of the drug that they received earlier that day, or $5. They were responding on concurrent progressive ratio schedules. So kind of our gold standard of effortful behavior and operant behavior. And you get a very similar, almost identical pattern of effect. The 5 milligrams still kind of hanging out down here at the bottom, and a little less dose orderly, but certainly still this facilitation of cocaine intake with those active superextant doses. And for any of you that are in this sort of sphere of med development and these phase 2A type studies, it's really hard to move drug self-administration up and down. Historically, really only drugs that work well seem to move it. So it's a low sensitivity, high specificity sort of procedure. So kind of surprising that we get even that much, or that we get that much of it. So that brings up a sort of natural question. You have this consistency across these measures, but inconsistency with the preclinical literature. And I like describing this experiment in the context of the preclinical data because it really highlights, when we do translational research, the importance of not only the homology measures, because we had a really good kind of matching up of demand measures preclinically and clinically, but also the homology of things like drug administration schedules and the compounds we're using. So I didn't mention it, partly because I want to mention it now, but preclinically, all of the drugs, more or less, that have been tested are very selective antagonists. So they're designer drugs that are selectively targeting orexin-1 or orexin-2 antagonism, and don't have off-target effects. There's a little bit of literature with superexant, but not much. And so this differentiation between what we actually use in the clinic and what we're able to use outside of it. They also are all administering superexant or the orexin drugs immediately before a test session. Superexant and other drugs are sleep medications. And while you don't see overt decreases in behavior in an animal, clinically, we're not going to be using a sleep drug during the day. And so when you start administering in this different schedule of reinforcement or a different schedule of administration that's chronic, that's not acute, and given at night, you can see a very different pattern of effects. So this importance of lining up what we do preclinically and within the human laboratory and clinically. And that goes both ways, of course. I've kind of been harping on the preclinical literature there, but it's important that what we're measuring in the human lab is also matching on to the clinic. So a little bit about behavioral economic demand. Analyses allow for this nice separation of behavioral mechanisms that can underlie drug reinforcement and do so in a pretty efficient manner that generalizes across species and contexts. And we talked about just one example today of using within a medications development pipeline that can help improve some of the efficiency of data collection. So the last thing I'll talk about is decision. Decision is making as restricted alternatives. And this is going to be very brief for those of you looking at your watch and like, he's going to run out of time. Sort of just an aggregation of a lot of things I've talked about today. And so by restriction of alternatives, a lot of the work we do when we think about substance use is in a very kind of strong silo of opioids used in the opioid use context, and we're interested in opioid use. But the reality is that when we talk about substance use, it's happening within a broader context of other drugs, of non-drug reinforcers, of various contexts. And all of that can help determine the likelihood of substance use and the likelihood of substance misuse. And so some of the work that's looked at this kind of most acutely uses these non-drug reinforcement or alternative reinforcer measures to look at essentially how often and how much do people enjoy doing things without drugs versus doing them with drugs. It sounds a bit simplistic, but at a macro level or this aggregate molar level represents this sort of balance between value and frequency of non-drug time versus drug time. The problem with these measures clinically is they're 54, 32 items, 320 items. Like, there's no clinic that's ever going to use that. And so one of the things that we've been working on, and this is work with Sam Acuff, who's now a postdoc up at MGH, Harvard Medical School, looking at single item measures and looking at how well they predict treatment outcomes. So this is some work with a National Treatment Outcomes Assessment Group. So they work with about 88 clinics across the US. This is data from about 6,000 folks that are in a mixture of intensive outpatient and residential treatment programs, and looking at the prediction of treatment outcomes 1 month after exiting formal treatment, whether that be a residential or IOP program. And so two very simple questions, essentially, how hard is it for you to find things that aren't drugs? So very easy to find, all the way up to nearly impossible. And how much do you enjoy doing things that aren't drugs? And so what we find is in terms of that relapse or return to use rate, there's this just dramatic association here. Pardon me for the lack of error bars, but there's so many people that it just gets a little, it's small. So it's both significant and a meaningful relationship, where we see this increase in the likelihood of relapse within that first month from 10 to 60%, kind of across the continuum here. And we can think about that the other way. So we often focus, I think, a little too much on substance use outcomes when we think about substance use treatment, but also in just general quality of life and life satisfaction. We see the similar dose-related relationship, where if you make it hard to find things that aren't drugs, and you make it not fun to do things that aren't drugs, people aren't going to feel good about themselves, and they're going to end up returning to use, which is somewhat tautological with how we think about substance use or how we should define it, but not necessarily how we posit this sort of potent nature of non-drug reinforcement. And so kind of the last little data slide I'm going to have, and then a little bit of summary, and then we can chit-chat about all this stuff, is going back to the preclinical world and kind of exemplifying this on that other translational spectrum. So this was some work with Mark Smith, who I worked with as an undergraduate at Davidson and continue to work with now. On the x-axis is fixed ratio cost, on the y-axis is consumption. So we're going to talk about demand curves, bringing it all back together. And so what we did was we looked at demand curves for cocaine, so cocaine alone. So this is just cocaine available in the absence of any other good. And you can see a pretty inelastic good. Animals defend cocaine pretty steadily across a dose range or price range. And this is what happens when a non-drug social partner was readily available. So still available for a response cost, an FR1 on a lever where it's raised a little guillotine door so you could see your little buddy. But it potently and robustly decreased this level of cocaine intake. So a decrease in both the intensity as well as the elasticity of that demand. But to kind of speak to that broader importance of understanding that context, if that partner was acutely injected with an IP injection of cocaine right before that session, that social protection completely goes away. And so you can see that kind of nicely here. So there's a decrease with the availability of the social partner, but that's highly dependent on the drug use nature of that peer. And of course, this kind of simplifies the clinical condition in a lot of ways, but speaks to that importance of the availability of not only alternatives, but non-drug alternatives in the environment. And kind of tying that back to some of the demand work. So I talked today a little bit about delay, but there's a whole host of different mechanisms that underlie choice of decision-making, the probability of occurrence, the efficacy of an outcome, the social distance has with another person. And all this sort of wraps into this broader theoretical perspective and thinking about substance use and thinking about how we measure it and treat it and develop interventions that again, Sam here, along with James McPhillip and Jim Murphy, recently wrote a really, really nice theoretical / commentary / review type of paper in Nature's Reviews Psychology about this sort of contextualized behavioral economic or reinforcement pathology approach to understanding substance use. And the idea here is that we all have our own way of thinking about substance use, either at the neurobiological level, the personality level, this behavioral economic level, sociological level, and all of those are determinants of substance use. It all works in concert. But the nice part about this sort of lens of thinking about it in this way is it kind of situates itself nicely in between the within-person determinants, things like the neurobiology of the person and their history and their genetic predisposition or personality predisposition, with all the environmental determinants we know, the socio-cultural structures that substance use happens in, the legal structures, the policy structures. By thinking about this sort of interaction of the individual and their environment, the temporal windows we summate over, the access we have to alternatives, the access to non-drug reinforcers. And so certainly that's profoundly new to anyone that thinks about this stuff, but a nice way of conceptualizing it as this sort of linchpin of thinking about this interaction between the within person environment and the extra person environment, or the environmental determinants. And so I'm gonna stop there and hopefully left a decent amount of time for questions. Here's Sam and another colleague at Hopkins, Austin Zamripa, us engaging in some nice non-drug reinforcers of cheesesteaks before an Eagles game. Go Birds! As well as a lot of the other great people I get to work with. A special shout out to Becca Schlitzer and Jess Harbaugh, who are RPC's research program coordinators that work with me, who do the amazing work of keeping everything afloat and are keeping things afloat right now. Our funding support, as well as other collaborators. So I'm going to stop there. I have contacts here. I don't have time to get to questions, or you don't have a chance to chat with me later. Otherwise, thanks for having me out here, and thanks for sticking around to chat.